Um, just again, thanks everybody for showing up for this. And I think what I'll do is, again, as I'm still figuring out how to, the best course of action to do this, I'll probably go through and describe, my planned stuff. Which this today I'm going to talk about the profiler plugin, and then open it up for any questions about this or anything else that you have. So it's sort of topic and then general discussion. I think well, maybe I'll do like just a brief rundown. The newest thing that I have that I've talked about a little bit, and I did the OIT demonstration, is all of the Rose Engine ornamental turning things. I'm still spending a lot of time working on that, and I've actually basically completely rewritten a lot of how it worked. So it'll be able to do things like eccentric chucking a lot better. So those will be things that'll coming in the very near future. So aside from the Rose Engine plugin, the Profiler plugin is the one that I have probably spent the most time on. So I'm overhead view here, so you can see how I've set up. I'm going to have things generally the same way as last time. I'll have a side camera here, software view, and then I've got a split view to be able to show both things. And it's always hard to come up with names for these things, and I decided that to go with the Profiler plugin after originally calling this the laser profile plugin, because the first thing it did was the intention was entirely that it was just going to be used with the laser. And as I started writing it, I realized that a lot of the code that I was putting into this could be used for other things. So the idea behind the Profiler plugin is always going to be that it is going to follow some profile. So that means that you also have to use the scanning plugin. So I'll be switching between these quite a lot. So I'll talk about the Profiler plugin first. We'll go to the scanning plugin, do some scans, and look at how to set everything up. So the very first thing is that the Profiler plugin gives you a variety of different modes. Again, you're always going to be following some profile of a scan piece that you have, but all the modes are listed here. So the laser mode is the main one, and there's a little the hover over here kind of tells you what it does. So the idea with the laser mode is that you're going to follow profile, and you can create horizontal basket illusion lines. So for those that have done these by hand, it takes a very long time to make those horizontal lines. And if you throw a laser on there, you can make that can be very, very fast. And you get control over where the laser points are going to be. That's another key feature of the profiler in general. Flutes is, for lack of a better term, this is the same thing that the laser does, except now you're actually cutting. So the laser is just going to follow that profile with turning the laser on and off. Now with the flute mode, it's actually you're going to use some kind of cutter, and you're going to have some depth of cut, and you'll be cutting into it. So it can be straight lines, it can be curved lines. All of that is set up in the parameters that we give it. The wrap mode is the idea that we can take our 3-axis G-code. So these are things that we would generate using Kirimoto, and I talked a little bit about that last time and how to use it. I'll probably be doing more on using Kirimoto and potentially other types of CAM software. But you take this 3-axis G-code, and then you can actually wrap it onto the surface. And I think this is maybe not the best terminology, again, because oftentimes when people think about wrapping, they think about the idea that you're going to wrap around a surface. And that's not the idea of this plugin. It's actually to take some object, and then you place that object onto the profile itself. It doesn't mean you can't wrap it around.
To the object then?
What was that?
Are you mapping it to the object?
Yes, you map the existing G-code onto the profile.
So is that your term?
What's that?
Is that your terminology then? Map it?
Yeah, maybe mapping would be the better terminology. Let me write some of this down so I don't forget. Of course, I'll have a recording, but and you'd think I'd have a pencil somewhere nearby, but of course I don't.
So with the ideal of wrapping, I would take that as being something you're going to start around around the object, and it's going to meet back up with itself.
Yeah, that's not what this does. at least not explicitly. You could make it do that, but that's not the intention behind this. So I'll mapping might be the better terminology to use in this case. And I'll sort of explain it, and I'll even, yeah, that can be one of the things that we do. I'll pull something out and show you how that actually works. And the last one, go ahead.
I was going to say, I think Aspire uses projecting onto the surface. So that way it's not ambiguous whether you're wrapping or mapping, but it's sort of projecting it onto the surface.
Yeah, and what you'll see is that I actually have a button as to whether or not. So I think of the projecting as being sort of in two different ways, because the mapping is going to map it without respect to the diameter of the piece. And I might have this actually backwards. And then the projecting in this case is actually that you maintain the geometry of the G code while taking into account the diameter. So I did struggle a lot with trying to come up with the right terminology, and I clearly haven't yet, but these are all.
That's a good distinction, and mapping makes more sense given that.
Right. And this last one is the facet. And so the idea of the facets are that you're going to cut a flat, and it doesn't necessarily have to be a flat. The other thing that I have in the facet mode is the ability to invert the cut. And if you do that, you're not cutting a flat. You're actually, I'm still in the overhead mode. So the facet mode is, and sorry about the black lines. Tell me, is this still acceptable without that light on?
Looks good.
Yeah, I can see it.
It's a little darker, but I don't have the annoying LED line. So these are facets which are cut here, which give you flats across here. And then if you invert that, and there's just a button to invert that switch to these scallops that you cut across. So those are the same thing basically. So you use the same mode to do either of those types of pieces. And again, just while I'm here, I guess the laser mode is cutting these horizontal lines. So you typically have to scan the surface before you put in the beads, and then you would determine the distance that you want for any of those horizontal lines, and then tell it how many segments you're going to have. And that's the one thing that is for all of the profiler plugins, is that you give it a number of segments. Even if you're doing the wrapping/mapping, you could have it repeat a pattern multiple times by just telling it to do multiple segments. So there's no smart logic to make sure that there aren't any overlaps in doing that. So you have to actually make those calculations yourself before doing it. But that is I guess I didn't bring that one here.
So
I'll go get
with the beads, are you also have the opportunity to burn all the radial lines, or just plan on just doing those with a wire burner?
It's going to be easier to do it with a wire burner. I actually did burn these with the laser itself. But in that case, it's actually, you can write like 2 lines of G code to burn those. You just move it to position, tell it to start the laser, and then rotate 360 degrees. So it's almost that, because you'd have to position each one anyway, it's not something that's really worthwhile to do in a plugin, if that makes sense.
Yeah, it does, because the beads are going to vary depending on how you cut it on the lathe.
Right. So you have to actually position the laser each time when you're gonna do one of the radial lines. All right. So back to software view here. So those were facets. I'll start with, I'll just select laser mode here. So, and I'll kind of do this and go through, and a lot of these are going to be the same for all of the different modes. The first thing we do is we select the mode, and then we have to select a scan file. So I'm just going to pull up one of the scan files that I have now. So this is some beach bowl that I did recently. And so this is what it looks like. And the main thing that we have anytime we're going to pull up a scan file is that we have the direction that the scan was placed in. So it always will start with that direction. So this is an x-axis scan. So this is our, in this case, this is our independent variable. and our dependent variable is the z-axis because that changes. So we're going, in our scan, we set some parameter for how far apart all of these are going to be. And these are all 0.5 millimeter. As I move along this, I can see that to be the case. So the one of the parameters that we're going to need for every single profiler operation is this rotation center to distance. And what this really means is the tip of wherever our cutting tool is to that center of rotation. And the reason for that is that this plugin will rotate that B-axis to follow that profile at all times. So in order to know what angle it needs to adjust that at, it needs to know what that distance is. So we have to put that in. And that will be, before I actually do anything with the profiler itself, I'll actually show you one way that you can use to get that number. The other thing that every operation is going to have is the segments. So, and I think if I hover over here, so it tells you for all operations, this is the number of the times that the operation is going to be repeated by some angular offset. So you take 360 degrees divided by the number of segments, and that's how much it's going to move between each of those operations that you would have. Does that make sense? Okay. We have a nominal feed rate. So one of the things that this is an area that still I need to develop a little bit better. The nominal feed rate is in millimeters per minute, which is this sort of, I'm trying to provide a standard for how fast everything's going to move. And because we're moving the B axis and potentially the A axis simultaneously here, it's not as straightforward to make that feed rate be perfectly at say 200 millimeters per minute across that whole cutting path that we're going to have, or the burning path in this case. So if you have large rotations of the B axis, for example, that feed rate is not going to follow the profile at exactly 200 millimeters per minute. So I'm still working on doing that, but this gives you sort of a baseline to adjust what the speed would be. I would say 200 is slow, 1,000 is fast. And you kind of have to get a sense, I would say, playing with it a little bit to see what would be appropriate. And particularly for the laser here, you can adjust both this feed rate and the laser power in order to, if we're burning beads, for example, or burning these horizontal lines, to get the appropriate depth of burn or the amount of burn that you want in each of those. So one thing that is
your diameter would affect that too, right? Because if you're a smaller diameter, you're moving you got less linear distance that you travel per degree.
Only if you're dealing with the rotation, because actually for doing the horizontal lines, that shouldn't matter, right? Because it's basically thinking that it's just a plane.
I got you. That makes sense.
The diameter shouldn't, that's one of the things it's trying to compensate for, is that it shouldn't matter what the diameter is so much in this case, which is not totally correct, but that's what it's trying to adjust for. Because in this case, you don't need to tell it what the diameter is, because you're just moving across a surface, right?
Yeah, that makes a lot more sense. I was thinking wrong on that.
Other things that you'll find in all of the operations is a maximum B angle and a minimum B angle. These default to basically the maximums that you could have. So again, we are at minus 90 right here in the view that we're looking at the top. So, we could, in theory, we could go all the way to plus or minus 180 degrees all the way through this, and that would cover the full range of this. There are cases where you need to adjust these, and most of the time that's when you're working on the inside of a piece, because we have a certain range that we can go, that the whole x-axis can move back over here, or move the x-axis. So this is actually a z movement. There's a certain amount that you can move back here. And when you're rotating the tool around, if you're trying to do just the inside of a rim, it's going to try to move the tool way, way far back in order to be able to get the inside of a rim. So you can adjust that, and it'll compensate. So it'll know that you can still reach that point, but you'd be at, for example, a smaller minimum B angle in that case. So you have to, again, this is a case where there's still not where it'll detect everything for you. You have to go through and you have to play with it a little bit and make sure that your tool can reach all of these places that it needs to go. Though the ability to be able to do that is in the plugin. So you can tell it, and I'll show you in a minute, we can establish a target position and make sure that our tool can reach that particular target spot. And the other thing that I think all of the operations except for the wrap has is this A-axis rotation. So you can put an arbitrary amount of rotation of the piece to make things spiraled, essentially, for anything. So I haven't done it yet for burning basket illusion beads because I haven't actually done any basket illusions, but you don't have to have straight lines. You could essentially have curved lines for all of those, which might be an interesting effect in some areas. And you can do positive and negative angles to move in different directions for those. And the one thing that we have for the laser itself is a test pass. So this is to do a test pass to make sure that it's going to move the way that you want. So it'll do one pass around.
Hey, Paul, can you move to your software view?
Oh, yeah, I'm sorry. Thank you. Yep. So this is the test pass button. So you click that and it'll do, one movement, and it'll check with a weak laser power to make sure that laser is where you want it to start and where you want it to end. And then it'll pause, and then you can click start again.
I think you may have to roll your screen up some too.
Oh, really?
There we go. Now I can see it.
Huh. I can see it on my Zoom view, so it must be cutting off just a little bit. Okay, so this is what you do for laser things. Oh, there are super advanced features, which will be, these will always be there. So this is, you can adjust the step size and how much smoothing you're going to have for the rotation of the B axis. And these are reasonable defaults I found so far, but there might be reasons why you want to change that. So I'll just point out that those exist. Fluting has all of the same things now, except for being a cutting feature. It has the total depth. So this would be the maximum depth that you're going to reach. And the step down is how deep any of the individual cuts will be. It also has lead in and lead out, which effectively mean how many millimeters it takes from the start or the end to actually reach the full depth of cut. This is just a way to get sort of, when you're thinking about fluting or sort of even some of these things people will call scalloping, so that it would kind of have a smooth internal and external cuts as it's coming out of that. The wrap here, this is where we have to start adding some additional parameters to this. So one is that you have to pick a file that you would actually be wrapping onto this. So in this case, these will all be present. Let me go over here. You put these in this wrap folder. So all of the files that are in this wrap folder are present here. And these are just various things that I've done here. But I'll select this hexagon, this 30 millimeter hexagon here. And the other piece of information that you have to give it here is that you have to tell it what the diameter is at some reference point. So usually that diameter is going to be at the 0, 0 point. So you put in a number here, let's say 120 millimeters, and then we have these marker selections. So this is present in all of them, and there'll be different options depending on where we are. We can set that diameter reference. So we would set that diameter reference to be 120 millimeters at that 0, 0 point. Again, we have to provide rotation center to surface. I have this defaulted to 0. The reason for that is I've often forgotten to change that number when I'm doing things, and it'll throw up a warning that you don't have a number there. So I like to keep that at 0 and make sure that I have to input the number every time I'm doing something. Is this, yeah, I'll just go ahead and do that here.
What does that setting mean, rotation center to surface?
That's from the tip of the cutting tool or the focal point of the laser to the center of the B axis.
Got it.
And again, I'll show you that. I'm just going to talk about these a little bit, and then I'll show you how I actually get that value then we'll do a scan, and then I'll show you about how to set points on all of these things. But the whole idea with this wrap is that we have some G code, and we can set the main thing that we do is that we set where the operations want to be. And I'll show you this for the wrap, but it's a similar feature for all of these. We set a maximum limit. So the maximum is the maximum X value here. So if I set that, let's say here, it says that the max is at 32 millimeters on our scan. And I can set the minimum, and I'll set it here. And you'll notice it pops up this little number dialog here. That width is the width of our wrapped/map G code. So it actually determines that when you upload the file, it does a profile scan. So it looks at all the G code coordinates, and it determines that the width of that G code is 30 millimeters. So that's why my hex is 30 here. And the profile distance in this case is that it actually is doing a little bit of calculus here to actually calculate what the distance is between these 2 points along the path that we have there. And you can see that our profile distance that we have selected is just a little bit too large by almost 2 millimeters. So we could move this here. Now we're getting closer. We can move just a little bit more, and probably we're better off moving it back just a little bit here. So 30.37. We would try to get our width and our profile distance very, very close. And the whole thing is that this will actually scale our G code. So if we had our profile distance and our width at very different settings, we'd have scaled G code and things wouldn't look quite right. So this will also define where that G code is going to get mapped onto that surface. So if we don't want to map it here, if we want to actually map it closer towards the rim, well, I can move this here, and I can move my max selection, and I can try to get to about 30 there. That's pretty close to 30 there. So now that 3-axis G code would get mapped onto the surface right here. So that's establishing where we're actually going to do that wrapping/mapping of the G code, as well as setting to make sure that our profile distance is correct. I know that that's maybe a little bit abstract. Does that make sense in general what you're doing? You have some width, known width of the G code, and you're trying to put that into a known width on the profile, basically.
Yeah, this makes sense to me.
Okay.
But irrespective of that width, it will scale the math will happen, and it will scale the G code.
Yes, it will.
Okay.
So because it also has to scale in the, so this is all X, Z here. It's going to also scale in the A dimension, and that's why you gave it this initial diameter here. So it will actually know what the diameters are all along that, and so it can do the proper diameter adjustments. And oh, actually, I should say that is if we select this project button right here. So that will give you the same geometry that you have in your 3-axis G code as onto the profile of the piece, as you would have if you were cutting it, in 2 dimensions.
Where's the project at?
What's that?
Where is the project at? Oh,
sorry, yeah,
thank you.
it's cutting off. Can you see it now?
Yeah, got it.
Okay, so if you don't have that on, it won't adjust for the change in diameter of your piece. So it will conform to whatever the diameter changes are that you have. So if you had something that was very long, and if our diameter is, presumably this is the profile of a bowl, the diameter is going to be much smaller here. So all of our points are going to start getting compressed together as you get further down there, and everything would be wider up at the top. So, but if you turn this on, it will adjust for that. Now, if you're thinking about like wrapping around a surface or something, it doesn't work quite as nicely as you'd think, where like, oh, I want all my text to be, perfectly uniform across doing that whole thing, because it will try and put it across that whole, and it actually warps the text more when you're trying to use the project for doing that. It's almost better to just use a narrower window for your text, and if you want something else, you change that and not use the project. I know that I'm kind of describing this without actually showing it, which is which is sort of hard to do, but we'll come back to this one.
This may be jumping ahead, but does this work for non-circular, non-symmetric? So like an elongated ellipse, would it wrap further around A?
It
Or
will.
would it choke?
No, it will. It will do it. And I'll show you that in a minute, because you can see here under the super advanced features, there's maybe you can. I don't know if you can see all the way down here. Can you?
Yeah.
Yeah.
Ignore ovality.
Ignore ovality. So you can actually, when you're probing, you can probe and look and actually probe for the ovality of the piece. So if you have an oval bowl, you would probe for the ovality of that. Now, I have to think about.
I was thinking the other way around. I was thinking if you had an oval G code, will it wrap it farther around A? You know, say you're putting an ellipse on the side of this bowl.
Yeah. No, it will. It will. So whatever your Y dimension is for your 3-axis G code for the ellipse, it will scale that based on this diameter that you've given it to put it onto that piece. So basically, whatever the center diameter is of your full width of your G code, like let's say, that's going to be somewhere around here. So I don't know what that diameter would be. We could calculate. So -10, so it's about -15, so it'd be about -30. So it'd be about, the diameter would be about 90 actually at that spot. It will basically put that oval onto the side with a diameter of 90 when you have it set up like this. So if that was your oval, your Y dimension on that, it will set it to be that Y dimension.
Okay. Thanks.
And I will say that this wrap/map is the most complicated of all of these things. So it wouldn't be the one I would start with when you're playing around with the profiler. I would start with doing a simple flutes, or even the facets are going to be overall easier. So the facets also require, so I have these two at the end because the facets also require a diameter at the reference point. Because if I go back, maybe I'll go to my split view here, so we can look at both of them at the same time. If we look at the faceted piece again, one of the things it has to know is it has to know how deep to cut in order to make that flat across the piece. So you have to actually give it the diameter at the rim, or you have to give it a diameter at some reference point. So the rim is always the easiest place to do it, so that it knows how deep it would cut to make that flat. And that's going to be also dependent upon how many segments you give it. So the more segments you give it in order to make that flat, right? If you gave it 96 segments, you're going to approach something that's circular. It's going to take off very little. If you gave it 4 segments, which is I think the minimum you can do, it's basically going to make you a square bowl, but it's going to cut off a whole lot in the middle in order to make that a square bowl. So that's why you have to give a reference diameter in that case as well. And then all of these other things are essentially the same, with the only modifiers that we have here being for if we're going to invert the depths. So that's to make the scallops instead of the facets. So doing that again. And then there's also this depth modifier, which you can put in here. So if you don't actually want to cut the full depth, if you want to actually say cut only half as much off, so that would not make it a flat facet, that would actually still be sort of a rounded facet, you could do that. You could put 0.5 in there, or in the case of this one here, I actually just increased that value to about 1.5. So you can see rather than being flat across here, now it's actually concave. So those are examples of concave facets. And again, in almost all of these cases, you can also give it this A-axis rotation. So that's the arbitrary rotation that it will do for each of those segments. The other thing that for doing the facets is that you have to give it the tool diameter and then the step over. So the tool diameter so that it knows how many cuts it's actually going to have to make, and the step over is how much it's going to go over from the previous cut.
Hey, Paul.
Yep.
If you put a negative value in for the A-axis rotation, it'll curve back in the opposite direction.
That is correct.
Thanks.
And the only other thing I have under the super advanced features here, what often happens when you're doing these facets is that you make initial deep cuts, and then you start making very, very shallow cuts. So again, in this case, for this one, all the cuts towards here are very, very shallow, and then the cuts here are deeper. So, and it's going to make multiple passes depending upon what your step down value is that you have there. And sometimes you get cuts that are very, very shallow. So I have this adaptive feed rate. So if you turn this on, you can enhance how fast, like it, if you had a zero depth cut, that would increase the speed of the cut by 3, just so that it kind of scales so that you don't make very, very slow cuts for even things that are not cutting very deep, basically. Right. I think that covers all of the modes and kind of the individual parameters for all of those modes. So let's go back to this top view, and I want to show you how to get that rotation center to surface. Again, this is going to be dependent upon what tool you're using, and I'll go to the split view so you can actually see what I'm doing here. Oh, I think since the last meeting, I think I added this to the latest update. So when this box is in green, that means that you have keyboard focus. So that means you can use the keyboard keys to move things around. If, for example, I'll just zero this now. You can see that turn black because I clicked that 0 button. That means I no longer have focus there, so I can't use the keyboard keys. So I'll click anywhere in this in this area here, and that'll give me that focus again to be able to do the keyboard keys. Let me adjust camera there. I have a cutter on here right now, and again, the one thing that I always do at the beginning and when I'm starting off is that I set the B axis to 0 and I zero everything out. In this case, I restarted the machine, so technically my B axis is actually at minus 90 degrees. It doesn't matter for this point, but I'll make sure I adjust that in a little bit. But what I'm going to do is I'm going to actually drive this onto a point, and this is what I use for doing paper chucking, but it's nice that it has a grid, so I can actually pick out a point on this grid right here, and I'm going to go up and I'm just going to touch the tool onto that grid spot. And I'm just going to do very small steps here until I see that it's touching. And I'll go ahead in this case and I'll zero everything, or I'll zero X, Z, and A here. And what I can do now is I can actually rotate the tool. I'm going to move camera over here. I can rotate the tool back 90 degrees, so to the 0 position like this. And then if I move it back here, I should actually, as long as I'm relatively square, so I'm going to measure from the same spot, I can just put a ruler on there from this position to the end of my tool, and that will actually give me the distance from the tip of the tool to the center of rotation. So what I actually like to do here usually is just move off 5 millimeters first, and then I can go do a 90-degree rotation for the B axis. So I'll rotate this around 90 degrees. And now I'm going to go back to 1 millimeter, and I'm going to move this back, and I'll go to the overhead here so you can see I'm just driving this over. And now somewhere under here, I've got a measuring device. And so from that spot that I had it right the first time, I'm just going to put this on here. And this is very close. So that is 141 millimeters is my distance that I have right here.
Did you go back in the 5 millimeters you backed
actually,
off?
I didn't. That's a critical thing to do, which I did not do. So
Okay.
right. Thank you for pointing that out. I have messed that up more than once, right? Actually, that looks, yes. So that's now that would be 136 millimeters that I'm measuring right there. So what I typically will do now is, and I have these little collars on here to be able to keep a set distance, but now I can just, from a fixed position, I can measure how far that's sticking out. So I use the router body itself because that's not going to change. So I'll put my ruler up here, and I don't want to get in front of the way of the camera, but basically now I can measure out how far that is, and that's roughly about 53, 54 millimeters, and you can be close to this. So I would say that that's 54 millimeters. So I know that with the tool sticking out at 54 millimeters, that was, or with a distance of 54 millimeters, that was 136. So I now have an equivalence. And now, as long as I haven't moved my router around, I can put any tool in there and I can just measure from the base, from the face of the router here to whatever that is. And then I can just do the subtraction to have the amount of stick out of the tool. And I know the rotation center to the end of the cutter.
So Paul, the collars you got on the cutting bit there, what is that? Is that just an O-ring or?
Yeah, it's just a 3D print. I think somebody asked for the file before, and I'm not sure that I ever put them up there. But they're just little 3D prints that I slide over the 1/8 inch shaft of all of these tools.
So it's just a good friction fit.
Yeah, it's a friction fit. And if you do happen to plunge them deep into your bowl or whatever when you're cutting, they will just explode and come apart. Because I've done that a couple times. So that's where we'll get that number from for the profiler. So let's see. So again, the other thing that we have to do is we have to do a scan. So I'm gonna go back to the overhead here I'm gonna change this out. You'd think I'd have all my tools ready to go. So I'm gonna put the probe on, and as of right now, there's no way to directly generate scan data without a probe, but I'll show you that it's not a complex file. All it really does is it makes a text file. So you could, in theory, even if you don't have a probe, you could do measurements directly with the tool and then just input these into a text file, and you would get the same information. I've been meaning to add to the scanning plugin a way to automate that, but I haven't gotten there yet. So
Paul, are you using a new nut for every tool?
on the router?
Yeah.
No, I keep certain things that I use often. So with the probe, I just keep a collet on there because it's a 6 millimeter shaft on the probe. And so I just have a 6 millimeter collet in that nut. I bought a bunch of extra of these things because they were so cheap. So I have a bunch of extra of the ER11 nuts floating around.
Good idea. I like that.
All right, so what do I have here? This is what I'll scan. So I'm going to move this off. So we'll just give me a little bit of room here. This has a big old hole in it, so. And I did have it marked, but doesn't matter too much. All right. So for doing the scanning, I should probably get another view where I have the overhead along with the computer here. It doesn't matter what angle the probe is at least for these touch probes, because these touch probes, you'll see here when I trigger it by hand in the sort of the green box, you can see the probe getting triggered as I'm touching that with my finger. You can't see me touching that with my finger. There. I just always do that to verify that the probe's working. So you don't, if you forget to plug in the probe, you'll crash the probe in when you do a scan and it'll bend your tip on there. It doesn't really matter what the values are for doing the probing, in the sense that, oh, great. Of course, I've managed to mess something up right away. I had the cord was stuck in the B-axis belt when I tried to rotate it.
You're doing these things so that we don't feel bad when we do it, right?
Exactly. Yeah, I still mess things up quite regularly. So I'm rotating this around, and I'm kind of, I sort of usually try to get something that's similar to the profile, just so that I know that I'm not going to crash the sides of the probe into the piece. If I had it, depending on the curvature of my piece, if it was highly curved, and I'm probing straight in like this, then I have the potential to run a side into the piece. But if I'm set up like this, that's not going to happen. So all I'm doing is I'm moving to the front edge. And I think you could scan in either direction, but I think most of the time it's always going to be easiest to start at some easily measurable thing, because what I should have done, which I didn't do, is actually just measured the diameter across the rim. I'll just take it off in a little bit and measure it again. So I moved up on
the cable. Is that power and data or just data?
It's power and data. So if you buy one of these probes, so this is the probe that I'm using, and a lot of them will look like this. It will come with a USB-C connector on this end, and you'll have 3 wires that come out on the other end. And I think Margaret just got hers set up recently. So black's always going to be ground, red's going to be power, and then you're going to have either white, yellow, or blue, which is going to be your signal. And I have on the Discord, I think it's on the Discord.
You've got a suggested list on the website page.
Right, but I was meaning a profile of the actual control board with where those go on to, which header those go on to. If that's not on there, I'll put a note to make sure that I put the pins on the Discord.
And this is a 3D probe, correct?
Yes. And what makes it 3D is that it will trigger in any direction. So straight in, left, right, up, down will trigger the probe.
But it won't trigger straight in.
No, it'll trigger straight in as well. It'll trigger in all directions. So it's spring loaded, and as soon as it breaks that spring tension, I'm not sure exactly what the mechanism looks like, but it'll trigger in any direction. So now this is where we go to the scanning plugin here, and we're going to do an X scan in this case. So we have X scan, and we're going to go in the positive direction, and this is where we can give it a reference diameter. And I think this didn't work in the very first info session that I did, but if we were to measure well, you know what? Let me just measure the darn thing now so that. 170. Somebody remember that. So I can put in 170 here. And this is only matters if we check this create STL. So that will actually then use the profile, and it'll create a 3-dimensional model of the piece based on the scan profile that we have. So the other thing that we need is our scan length. So in this case, again, what I typically will always do here is I just hold this up, and we don't have to go very far. This is not a very deep piece. So that's about 35 millimeters. So we'll put in 35 here. And our increments can be sort of anything that we want here. Just to make this go fast, I'll put in 5. So this is our independent variable. So we're going to be moving every 5 millimeters over on the x-axis and then probing on the z-axis. And our pull-off here, we're going downhill in this piece, so we don't need a very high pull-off. And this is some, I don't know, we'll call this info 1 here.
So using the pull off, that would be very useful if you had like an OG on the outside.
Yes, so you can, and again, I could probe this going from this direction to this direction, and I would need a greater pull off to make sure that I pull off far enough so that when I go over 5 millimeters, I'm not already touching. So you have to gauge your piece and how much that the pull off is just going to take longer to actually do the scan. So, and it doesn't take that long unless you start doing these ovality scans. So I'm not going to do that because of the hole in this piece, and I could make sure that I don't hit the hole. But this will now actually do multiple scans. So if I did 6 scans, right, it would do every 30 degrees. No, every 60 degrees, it would rotate the piece 60 degrees after doing a scan, and then do another scan, and then rotate the piece 60 degrees, and then do another scan. And that way, the rest of the profile of the plugin will be able to compensate for the ovality of that piece. So if you're making a cut, and we're doing something like when I'm copying Pat's ribbon edge bowls, like this, where you're using these are flute cuts that you're cutting on the inside to a certain depth. It makes sure that, you know, if your piece is oval, that depth of cut will be constant, whether it's the inside or the outside. And now I can just click here, start scan, and scan increments are greater than length. Well, no, I don't think they are. Have I managed to break the scanning plugin again in the middle of a demo? Scan increments 5, pull off distance 5. Huh. You know, I'm quite positive that I haven't made any changes to this plugin, so I'm not sure how I've managed to break it since. Maybe I put in something weird here. 170, scan length 35, scan increments 5, 3, 12. Okay, yeah. What do you know?
Are you scanning in a positive direction?
Yeah, that should be positive scanning. Positive direction is correct. So let me do this. Let me make sure that I just gonna install the so now we also now have instructions on how to install a plugin manually. Reference 35, 5. Well, I broke something. Good thing nobody else is trying to use this. How could what? I mean, I used this like 3 days ago. Scan increment. Scan increment greater than length. Okay. Obviously, there's some bug that I have to figure out. So it's scanning now, as you can see. And it gives you the scan in real time here. So
Is the pull-off from the last point?
yes.
It's hard to tell at this angle.
Yeah, I don't have the best. Look at the overhead. So there, we made it all the way to the end. Now, one of the critical things with the Profiler plugin, and I think maybe I said this, is that the 0 point that you set has to be specific to what kind of scan you've done. So having done an X scan, and if we go to I'll just go to software view here. We'll do something in we'll do a flute mode first. You notice that it has, here's our scan file. We also said to do an STL, so there's an STL file, but we have to select the scan. So that is our scan that we just did. The one thing that we have to make sure that we do is that we set everything at 0, 0, 0, 0, basically. So our 4 axes, everything has to be 0 at that point. And I'll show you what that looks like here. I'll just stick with this end mill.
You want to go back to the dual screen?
I will in just a second. So I've just put the end mill on here. Let me see if I can, maybe it'll be better over here. Yeah, I think this will work better. So I need to set the B axis to 0. I haven't done that since I restarted the machine. So I'm going to eyeball this. We'll say that that's about 0. So I'll set B to 0 here initially. And now I'm going to drive everything over till I'm just at that edge. I can tell that my B is not quite right, but that's okay. There. I have to look over the top of it here. And I'm setting the, oh, I went too far. I'm setting the center of the cutter here right on that 0, 0 point. And so I'm right there now, and this is now where I would set all of these, including that B axis. Everything needs to be 0 at this spot. So we're right there right now. What I can do, I have to set this rotation center. So I forgot what I measured that at. 136 was where I was for that. So I'm going to set that rotation center. And now, before I do anything else, I want to make sure that I have that it is mapping that profile correctly. And most of this comes from having that B-axis angle correct. So if this B-axis is not actually at 0 right here, what we'll find is when we try to move to a position, we'll either jab into the piece a little bit, or we'll be off of the piece a little bit. And so that all comes from, we can recorrect the B angle to make sure that when we start moving along this profile, it'll be all at the correct point. So before I do anything else, I'm going to start to use this set target. So, and this is, again, you can use this with all of these profile pieces. So I'll click a position here. And then now I have to be a little bit careful about where the camera is going to, things are going to move here. Set it there. So now I can use this. Can you see at the bottom of the screen, go to target?
Yeah, you can see it.
So now, again, verifying that I've set everything to 0 here, I will go to Profiler and tell this to go to target. And so now it's going to scoot back. It's going to rotate the B angle. it's going to move the x-axis over, and then it's going to drive the z-axis in to the where it thinks, based on our current reference, it should be. Now, we can look at this, and we can see that we're off by like a couple of millimeters there. So that means we don't have that b-axis correct. And so this is, oops, camera's loosened up a little bit. This is where the most of the setup in the profiler comes in, is to make sure that we're at the correct position. So what I'm going to do is I will just go back to the 0 point here, and I'll go to target there. This one will come out right, or close to right, because it thinks that this is where 0 should be. So actually, no, it's a little bit off. So that's fine. What we'll do is we'll adjust our position. So I'm going to scoot this back. I'm going to rotate B to where it thinks it's 0. So I'm going to click B here. I'm going to go home, and it thinks that that is 0. And I actually know from doing this that if the cutter is off of the piece too far, then what I need to do is I need to adjust the b-axis going in a more positive direction. So I'm going to just say take the b-axis, and I'm going to move it over 1 degree, and I'm going to 0 B again. And now I'll go back over, and I have to set the 0 for x and z again, because as soon as that b changes, the x and z change as well. So now I hit XZA, 0 that, everything should be 0. We can go back to profiler, we'll set the target here, and then go to target again. And that, I don't know if you can see that. Let's try to get it. That is now right on the surface. And I was trying to watch it, and I didn't see it actually gouging in. So that should be pretty good. So we were about 1 degree off. Now we can verify that. We can just go to another position. So to make sure that we can reach this spot here, we'll say go to target there. And now it looks like we really got it. That is just right on the surface of the piece. So if I've measured those 2 points and those look pretty good, then it should be fine for the rest of it. So now we're feeling pretty good about where we are with that. We could set up to do any of these types of operations. I'll do a fluting operation here because it's easiest to do. We'll do something simple. So I'll do, you know what? I'm trying to decide what the best approach would be to this. I'm just going to do a single flute. But keep in mind that we would do segments here because I want to leave open space because I want to come back to the wrap plugin or the wrap operation and show you what that does. So I'll put a pencil on there for that. So I don't want to mess up the surface all the way. And I'll put a little bit of rotation. Let's say I'll do a minus 10 degree rotation for this. We'll set our max. We'll be at whatever this current target position is that we're at, and we'll go to the rim of the bowl.
Do you need to select a scan file?
No, this is my scan file. So if I have this up here, that is the one that I want. And I'll increase this. I'll say I'll do 600. They're nominal, and we'll just do actually we'll do a double pass. So I'll do one where it's at 1.5. So the total depth is going to be 1.5, and our step down is going to be 1 millimeter. So the first cut will be at 1 millimeter, and then it'll do a 0.5 millimeter for the next cut. And so I'll show you that we can use this, the adaptive feed rate and I'll make this something real high for that second cut. So it'll actually do one pass at 1 millimeter, relatively slow, and then the second pass that it'll do will be very, very fast, since it's much, you know what? I don't know if I want to do 0.5 millimeter that fast. Let's do 1.2. There we go. That's better. Okay, so the other thing that I like to do is just move the position off, like back up to the rim somewhere. Oops, that's not where I want that. Set target here.
How much does wood species affect your feed rate?
You know, I haven't thought about it that much. It will definitely impact it, as at least as how nice of a cut you're going to get. But also it's going to depend on your cutter and what speed you have your router running at. So I think most of the time, what I'd say is that for doing a cut like this, I'd want the router, because there's not going to be, the B transitions are going to be relatively smooth for this piece. I'm going to want basically as fast as I could get out of this. So I might actually do a feed rate about like 900 and then crank the router speed up on this. And then it'll cut pretty fast and you'll get a nice cut out of it. If I had lots of B transitions, or if the B axis is going to be moving a lot, I would slow it down, and I would also slow the router speed down, so that when it's making like the B movements, if it was like having to undulate the B like that, it ends up being stationary at places, and that's when you end up getting burning, because the router sits at one spot too long as it's moving the B axis. Okay, so we're near the top here, and all we do now in this case is that we check everything, make sure it's all looking good, and then click Write Job. And Write Job, it actually did pop up a little thing that said that the job was being written, and we have our G-code file here. It's cut off a little bit, but it says flute, segment 1, our A rotation is -10 degrees, our depth is 1.2 millimeters, and we're using this X scan, and that was the name of the X scan file that we had. So I'm going to just manually back this off a little bit more.
So is it going to start the fluting from where you had it set at there, or will it go to the rim?
It's actually going to go, so what I have it set to do right now, and this is again some things that I've been changing a little bit, is that it should always start at the lowest Z dimension. The reason for that is that what I found so far is that when you plunge at the rim is usually going to be the weakest spot. So plunging at the rim gives you some interesting effects, particularly if you're trying to make a deep cut. When you plunge near the base, you don't have that same effect. So I've decided that it's always going to start at the most, I think that's how I have it set up now. It's always going to start at the most negative Z and then work this direction. Now, when it's doing multiple passes, it'll go up this way and it'll come back and it'll just do the pass the other direction. Unless, I'll show you, this is something that is not added into the mainline version yet, which is this single direction. If you have it set to single direction, it will only go one way. It'll start here and it'll cut here, it'll back off, it'll move, and it'll do every pass going in one direction from the base. And I found, again, in doing these things, because these can get very, very thin, it's much better to do the passes all starting in one direction and then working towards the rim, instead of trying to do multiple passes coming back from the rim to the base.
You get less deformity out at the rim.
Right, exactly. And it's always going to bounce around when you get towards the rim, but when you plunge and you're going at the rim, that's where it feels a little bit shaky. Okay, so I have my router set up to start automatically on a little automated switch, but I would normally flip the router on here and we'll just make this single cut. And I'll go to the top view for this. So So you can see it's going to the end here first. So simple, straightforward. You can see that there's a rotation in the cut that we have there. I don't know if there's anything else that, that was kind of boring, but at least it demonstrated what it was supposed to do. You see, right? This is 10 degrees from the start to or minus 10 degrees from the start to the finish of the cut. Any questions about that? Is there anything here that I did that, I mean, I don't want to say completely unclear, but is there anything that doesn't make sense for these parameters?
That'll come out when we start playing.
Yeah, for sure. But I mean, just if you have any questions about, so again, lead in and lead out well, maybe I'll do another one. I'll do a cut right next to this one, and I'll do a lead in and lead out of about 5 millimeters so you can see what that looks like.
So that just creates like a radius coming in, or is it just ramping in?
It ramps in. Yeah, so it's not going to have a very good effect with this small cutter, and this is a flat end mill. But if you use a ball nose end mill, right, you can actually you get the better look of what that looks like, and actually doing this this shallow a cut, it might not look that great, but that's okay. You can just write the job here because all I did is add the lead in and lead out. So it has the same file name in this case, so it actually overwrote the file that we had previously. I'm going to just set the A-axis. Let's see here. I'm going to rotate that so it's almost right next to the other one there. So I'm going to set A to 0 here. And I don't have to worry about any of the other parameters because these are all still referenced. All of the values that you see there are still referenced off of that point. So these are the correct parameters for this. So I should be able to turn that back on. Make sure that in case my thing doesn't turn on, I'm ready to do it right away. So here we go. And I don't know how obvious the ramp in, I think, is more obvious than the ramp out. You can see that it doesn't quite make it to the same spot because it's ramping in there. The ramp out isn't quite as clear, but there is a difference in the depth at those. Okay.
On the ribbon style bowls that like Pat's that you were holding up, is that a one pass cut, or is there a way to do multiple passes to increase the width if you're using a smaller diameter bit?
Yeah, right now there's no way to do the multi-pass cut. It's what you could do is do it in the same file in 2 passes and then just do an A offset. So you would run once and then offset it by, say 1/2 degree or 1 degree, and then run it again, and you would get a wider cut out of the same bit. But as of right now, it's assuming you're doing a single pass cut. It's something I can look into doing, because that actually wouldn't be too hard of a parameter to add, because I could just set it to do that additional A increment, and it would just be another loop that would basically do till you made sure that you made it all the way through. However,
No, it's okay. I wasn't asking for a feature request. It was more just clarifying, like on the pad example that you keep holding up,
no,
whether that was a wide bit making that whole cut, maybe in multiple depths. But
yeah, this is just a 1/4-inch end mill that's making all of that.
okay.
So the only, I like the idea. So I consider it a feature request, even if you don't want. So the thing that you look out for with this, and Pat will tell you, is to make sure that you have to know what the diameter is here, where you're actually going to start, because you have to decide how many flutes you can actually have here before you actually start to have them run together, which in theory you could still do it in this case because it's not cutting all the way through, but you have to watch out for that. So that would be something that, again, I wouldn't be able to build in, but you could say offset here by 1/2 degree, and then it would make the cut, and it would be something that would be wider there. Yeah.
Yeah, I think kind of in an ornamental turning approach, you would say, I want 96 segments, but I'm going to do 2 cuts and then skip 2 segments and then do 2 cuts and then skip 2, kind of that kind of mentality. But there's a jillion ways to do it. So I don't know.
Yeah, that becomes harder to put in. So I think I talked with
Right.
Pat about that a little bit. One of the things that you can do is, because it writes the file first, and maybe I'll pull. Do I have one that I had multiple segments? Here's something that I have 18 segments. I'll pull up this file and go to the screen view. So here's oh, that's a corn lathe file. Why am I looking at a corn lathe file? Here's the actual G code. So it tells you have in the comments of this what flute you're on, of how many. So you could quite easily do a little bit of parsing or some manual editing, where if I wanted to skip every other one, I just go through and I just delete the G code that's in between. For flute 2, I could get rid of that.
So is that all repetitive, or are you using macros?
It's all repetitive in this case because of the A-axis rotations. So
Okay. Yep, that's fine.
Yeah, the thing that you get out of this is that, particularly when you're dealing with the ovality. So if you've done an ovality scan for your piece, you do have to know what the A 0 point is in order for that to make any sense. So in that sense, I had to make sure that I increment this A correctly in that case. And the depth of cut changes as well, because as you go in each deeper cut, you can see here that I include, just so you're following so I can follow what's happening. I include that my depth of cut is at -1 millimeter there, and then the next cut here, right, that's the 2 millimeter cut to get to that full depth that I want. So if you like to read G code or parse G code or think about G code, I try to make it clear what's happening at all the steps. And you will see that these are using G93s. So this is all inverse time mode for all of these steps.
That's nice. It's very readable.
The only other thing to keep in mind is if you're going to use the A offset to widen the flute, make sure you're moving it in the proper direction on the inside so they line up.
Exactly. I have lots of different failures on the ribbon edge bowls and platters now, and I have like the rules kind of written down as I've been figuring them out, and I even said one of them is line up at the end of the cut rather than at the beginning of the cut, but you have to make sure that you line up at the right side of the end of the cut. And so I've messed that one up too. So, okay, I think maybe I'll do. We've been an hour and 15 minutes. I'll do one thing with the wrapping, because the other things, you know, doing the facets and the laser work on that is kind of the same thing of what we just did, more or less. You set the min and max points and all that. So the wrapping / mapping is the one that's kind of different. So what I'm going to do is I'm going to have to adjust my B to center in this case, which means I'm going to actually have to kind of readjust everything. But I'm going to put a pencil bit on here if I can find. You know what I'll try and do? I'll try and just set the pencil bit at the same distance. So let me measure what this was again. So 52-ish.
Can you go to an overhead view?
And this is, oh, sorry, switch view. This is what I'm going to put the pencil lead in. If I can find my pencil leads.
Before you put that into the router, can you show us that pencil lead holder?
This is a brass tube. That's all it is. With a 2 mil, I had to bore it out to exactly 2 millimeters, or actually slightly over 2 millimeters. There is a tiny 2 millimeter spring that sits in the bottom, and then I plugged up the base of that with some 2-part like putty stuff, like milliput. And the idea is that we can then put this in here, and now this is basically a spring-loaded pencil.
So it accounts for some of the wear of the pencil lead as it gets used up.
Well, that, and you can use the G code that has cuts, right? So that it's going to move it in, you know, X millimeters, and we can actually use it. So I'm going to have to try and set this to wherever we were with about 53. That's not too far off.
Spring loaded helps with ovality too.
And surface irregularities.
Yep. All right, we'll try that. I'm going to basically draw that hexagon, and I'll show you how we do that in the wrap mode, both in the projected view and the non-projected view. So I'll rotate. Oops, I don't need to rotate that. I'm going to hope that everything is basically still fine with my measurements, since I set it where they're on the same piece. I tried to set the tip of this at the same distance that our tool was before. And I'm just going to 0A here. So we'll go back to Profiler. I'm going to reload the page because I want to start fresh for this. So I'm going to select our info. We're going to go into wrap mode, and our diameter at reference, we measured this, was 170. So I'm going to set our diameter reference here at 0. That's was 170. Our rotation 136. We'll do single segment, and we're going to do this 30 millimeter hex again. So now we need to set our min and max limits. So I'm going to set it a little further over here, and our min. That's pretty close. There we go. That's close enough. So this now it's going to be fairly close to the rim. This 30 millimeters kind of big still for this. But I'm going to do this once with the project off. So I will now simply write the job here. And so here we have a wrap now, and I'm going to run this one first. I need to make sure I turn my router off. You don't need the router on for this. And in theory, I should just be able to run this now, and it will make a hexagon, draw a hexagon onto this surface. Okay, maybe not. Oh, I have it doing slightly different operations in wrap. I have not used the wrap in a while. You can't see anything. So let me... I'm going to set the bit out just a little further. I'll try that again. I'm not sure what the... I must have not adjusted wrap to do the same starting motions. It's moving back to the Z, the 0 position first. And you can see it bobbles a little bit in a sense. That's not a very good hexagon. But that's what happens when you don't have in the project mode, right? Because it's actually getting smaller here and larger here. So now I'll do it in the project mode. And if we run it again, it should look more like a hexagon now. So the idea was that it's compensated for, the lines are still not very good, but it's compensated for the, that's about 20 on that side. It's about 20 at that side. So the length of those lines are the same. It gives you an idea of how it works. Do I have anything else that would be of interest for this?
If you reduce the step size, does it smooth those lines out?
Yeah, I'm kind of surprised that those are quite as rough as they are. I don't remember it doing that before, but I haven't done this in a while. So let's try that. Let's see if it... And I might want to decrease the B smoothing in this case.
What is this point in space that it keeps going to for the start
It's
of the
going
job?
back to it's going back to the actual 0, the x0. Well, it's x0 z10 that it's going to in this case.
Thanks.
Yeah, it's not really any better, I don't think, in that case.
It looks like the lead is moving in your holder a bit too.
It is, yes, which wouldn't happen with a cutter. But we could do, let's see what a circle looks like. So this is still a circle with a width of 30. So I would say the wrap has been the one that I've worked on the least of all of these, because I just haven't found the need for it that much at this point. Oh, we're going to crash. All right, well. I would say that the wrap has not been fully tuned yet, but the acorns that I did, where is that? I'll be back. Just 1 second. So this was the thing that I had kind of developed the wrap for in this case, because you can take the, in Kirimoto, you can do these contours. So you take a three-dimensional object to start with, and then it will actually go through and do those contours. So that was actually done using that wrap feature, but it was done so that it was in this narrow band that was left here, and then it removed most of that band as part of that. So it can work. I don't know why, you know, obviously it's not up to speed yet, but it will do that. I just have to revisit it.
So with the piece you showed, you just reran it for every one of the relief cuts?
Yeah, so that was where I have the ability to do that segment value. So if I put the segments in here and I put 8, it would just have the G code be the full 8 that it would go through. It would do 1, rotate, do the next, rotate, do the next. And that would be a single continuous job.
On one of the facet examples you keep holding up, there's a bunch of striations. Is that step over or using a square end mill, or what's going on there?
That's step over, and that is just to kind of show you that's the surface that you get. So that it's because you have different depths as it's cutting across all of these, that you get the striations from the step over.
Okay.
Now, if you decrease the step over value, it would take a lot longer, but it would also look nicer. So, and here's the long example of this. So you can still see the striations. Oh, maybe I'll go to overhead. Right, you can still see the striations in this, but the step over was a bit finer, so they're kind of more uniform in this case. And the sanding on that would be minimal, really.
Is that a ball end mill?
Experimented by putting a small sanding pad in the router bit and can go slow enough.
I'm sorry, I missed that. Yes, that's a ball end. Can you say that again, whoever was asking a question?
Have you experimented by putting a small sanding pad, like a Dremel sanding pad, in the router bit?
I have not. I contemplated that you could use it for sanding as well. I haven't gotten there yet. So one of the problems is that
Could be researched.
Yeah, this router runs at probably too high a speed for sanding. You're gonna wipe out your sandpaper and potentially even burn the piece. The other router that I use for the ornamental stuff, that'll go a bit lower, so that one might actually work to do some sanding.
Consider an ornamental universal cutting frame.
Yes. So did I show you that one yet? Did you see that one? That's Alan, right?
Yes, that's it. That's Alan. I'm Alan.
Yes. I told you, I think I said in one meeting I was developing one. I'm not sure if you ever saw what I put together.
You showed it in the OTI meeting.
That's right. Yeah, I did show it.
You got some pictures on Discord.
Okay. Yeah, but this is oh yeah, I had a little mishap the other day. The one thing that is about the automated system is that, well, I guess this is kind of how the whole thing started. Most of the mistakes are like behind the keyboard. So you got to make sure that when you're telling it to plunge in a distance, it's the distance that you expect. So there's a big difference between 1 millimeter and 5 millimeters. And when you move in the universal cutting frame 5 millimeters when it's supposed to go in 1, it doesn't like it. So my belt got a little bit hosed.
So when you were about to crash with the pencil, I was wondering, is there a convenient pin location where we can put an e-stop switch that'll just stop all the movement?
Yeah, I do have. So they're wired in. I intentionally am not using the e-stop, so that the board itself hasn't. We can have an e-stop connection on it. I have a feed hold button, so I'll run again and I'll show you what happens with that.
Feed hold is fine. It's just is there a place is there a pin that we can put a button on so that we can have it?
Yes,
If we're not by the keyboard.
absolutely. So in this case, on my board, it's underneath here, so it's going to start the run. I can push the feed hold button, and oh, you can't see that because. And now, if I go to the control view here, you can see it's flashing run, hold, run, hold, run, hold. And then if I push the release button, I can just go between those two. Those are already wired in on the board. So let me see if do I have them on this. Yeah. So I just have 2 buttons on there, and these are kind of quite jankily put together, but there are on this header right here. You can plop in the ground pins and the appropriate pins, and you have feed, hold, and release already built in.
Can you throw those pin locations and maybe a picture on the Discord?
Yes, I will, because I have that in the diagram that has also the positions for the probe and the lasers as well. So I will put that on the Discord.
And do those go high or low? I mean, can we put them in series or parallel so we could have like one on the top of the lathe and then the one on the control box or something?
Yeah, so those are, let me think. My pins are normally closed, so they're active low. So it's taking it low to activate the pin.
Thank you.
I don't have anything else. I guess obviously I've got to go back and work on the wrap mode a little bit to figure out why it doesn't look as good as it used to.
Well, these meetings are just fantastic. I mean, I pick up so much information. I just wish I had time to implement it all.
Yeah, well, I need to get it down somewhere, and I have to say that I have all these plans to make videos that I'd put on YouTube, but man, I hate editing videos. It's just like one of those things I just can't get the motivation up. I would rather be sitting in front of my computer, writing the code and fixing things than editing videos. So
maybe the answer is just, don't worry about doing a 2-hour long session. Do a 5-minute short to just show a feature or something like that. No editing required, just raw.
Yeah, I guess I could do that. I always have these like plans, like I'm going to do this step and I'm going to show this step, and I feel like I have to describe it all if it's going to be in a tutorial form. But maybe if I just show features, that will be.
Well, as John says, if you get all these little segments together, then later they could be strung together with some editing.
Yeah.
I think some of the quick YouTubes where they do one topic in 3 minutes, very, very helpful, because you don't have to find it in the middle of an hour-long video, You might just not understand one piece. Yeah, one big overall video to sort of show you the breadth of the tool, fine. But the smaller ones, I think, for very specifics, are more helpful when you're trying to make your own project.
Yeah, I think I could do something like, with the flute cutting or even doing the laser burning lines. That could be done like very quickly and just say, okay, set your minimum, set your maximum, This is where
Right.
we're going to go.
Mhm.
All right, click start, boom, and here it's going to do it. And you at least, in that view, you see everything that it can potentially do. So, as long as I'm showing this view, you have all of the parameters, and people can at least see what parameters I put in, even if I'm not describing what all of the parameters are doing.
Well, I think people experiment and figure out what all those parameters mean. I have no understanding of it right now because I haven't even set it up yet. But if I want to find out how to just do a laser line, that would be helpful,
Right.
I do
It's
have,
really useful to have a single example. Here's what happens. Do this. Very short.
yeah,
And then you can experiment once you've got some concept of, okay, if I want it to look like this, example, do this.
Uh-huh.
yeah. Here,
Okay, yeah.
start with this, and then play with these three variables and see what happens.
Actually, the little pieces, the halos,
Yeah.
that one works that way because you start with that and it's very simple, very straightforward, and then you can play with it.
Right.
Yeah, I would vote for a series of very small segments as opposed to never having a big one.
Uh-huh.
Yes,
Right.
And I don't
please.
think anybody would complain about them being unedited. We would just getting the information available to us would be phenomenal.
Well, as you
That's
can
what I
see, though,
appreciate.
the problem is that I mess things up frequently enough that, that I never do a single video where I get everything right.
Well, that's the whole thing, you always be an
Yeah.
example, whether it's a good example or a bad example.
And
Well,
and you can replace a bad one with a better one in 5 minutes if you need to down the road,
Yeah.
or
yeah,
when a feature changes.
And
true.
seeing those mistakes prevents us from making those mistakes.
Yeah,
Yes.
yeah.
No, it doesn't.
Or
It
makes
just
us
allows us
feel
to
better
repeat
when
them.
we do.
Hopefully.
Well, that leads to a question that I'm thinking ahead because mine's not up and running yet either. But when I'm doing other stuff in CNC, I will, like on a regular CNC router, I'll intentionally set my bit. I'll zero Z0 an inch above my workpiece, and I'll run an error cut so that I can see that the G code and all the motions are correct. I'm having a hard time wrapping my brain, no pun intended, around how you can back off to say now just run an air cut that's some distance off of the surface to confirm that like your ribbons are going to line up or your plunge is going to happen where you expect it, things like that. Is there some place where you sort of think it makes sense to back off in one axis or one direction so that you can run an air cut that would be representative of what's going to happen on the workpiece?
Yeah, it's a little more difficult. I mean, you can back off. Like when I set XZ and X and Z 0 in this case, like, right, I'm not in the right window. When I set these, hold on. Oh, that's because I am,
Release.
yeah, well, if I release, it's going to keep going. I can just disconnect and then reconnect. Disconnect. Or I can give it a, there we go. If I was setting that Z0 position, you can't go crazy setting it off because you won't get your actual start positions right. But let's say that this was, oh, you can't see that again, of course. I just don't have good spots for cameras here. Right, when I'm setting this here, if this was my cutting tool and I was setting that as 0, well, I could back that off, 5 millimeters and call that 0, and it will still follow the cut that it would make, but it's not going to be. It'll go to basically the right position, and you can imagine where it would actually be plunging, but you can't see where it's going to be exactly plunging in that case. But you can make sure that it's going to be following the profile the way you expect.
You could also set your cutter in deeper into your router.
Yeah, that's how I was going to say the other way around. I was going to say, can't you just exaggerate the center of rotation distance and that'll hold it off?
Not as much as you'd think, because all that really does is that sets the B angle that it's going to be at. So if you set that center off, you're not going to go to the proper spot, because that B angle is not going to change to the correct, to put the tip of the tool facing the right location. Does that make sense? So it doesn't, like, if you increase it by, say, 5 millimeters, that doesn't guarantee that you're going to be 5 millimeters off of the piece.
Okay. Yeah.
It will change where the rotation will be, and depending on what the profile is, you might be just a millimeter away from the piece still when you've adjusted that.
Yeah, I think that's going to come into play when you really start using essentially your ornamental turning cutting frame, which has a full circular cutter in the horizontal, or typically in the horizontal plane. It's going to have a bunch of weird tool contact where you don't expect it if you're not used to it.
Right. That's going to be, yeah, particularly for a surface like this. Now, I will say that, I've been describing everything that I've pulled up has been a bowl so far, but that doesn't mean that that has to be your profile. So, this would be a lid of a box that I have here, and this is just using the profiler plugin. And I don't know if you can really tell that it's got sort of, how do I show that? Don't worry about what that looks like. Maybe at this angle, right? You can see that there's like a little top and a bottom, like there's a little lip at the top and the bottom. And I just, I scanned the cylinder, and then this is the lead in and lead out for that,
Yeah.
that makes that actually have this sort of the lip at the top and the bottom. So, and that's just with some amount of rotation, which is, it's I don't know, it's kind of cool. It's not very ornamental, but and I have added, so as part of this, again, these are features that are not here yet, but John's here, and I have to say I've been spending most of my time on the Rose Engine plugin here, not on other plugins. Is that I have the ability, at least in this pumping frame, that you can select X scans. So if I were to select a cylinder here, I would have to know what the 0 point of that cylinder is. But if I was actually pumping, so pumping would be going back and forth like this, it will actually compensate for the depth of your profile. So that, in some cases, if you're off just a little bit, you'll see that in the design that you have, and that way it'll actually compensate the depth as it's, or it'll compensate the depth as it's moving back and forth like this, basically.
It'll compensate based on the scan?
Based on the scan, right?
Okay.
So let me pull up, I'll show you the cylinder scan that I did here. So I don't have a way to pull it up there yet, but right, this is the scan of, actually that was this cylinder that I did here, was this one, I believe. But I was playing around with this. So, you can see that it's about half a millimeter, a little more than a half a millimeter off over here. And this is, in fact, I'll show you, I'm certain that this is I'll download this one and we'll look at it. This is actually a ovality scan. So, oh, you can't see that there. I'll just go to the full screen view here. So, darn it. So this is all of the scan dimensions at 0 degrees. So you have to know where 0 degrees is. And then I did 6 of them. So these are at 60 degrees. It's off by 0.7. And you can go through, and it'll actually, if you're at 180 degrees, it'll compensate for these X values. It would say cut deeper, because these are negative values here at those positions. So I don't know, does that make sense? Right. So
yeah.
Basically, as I would be traversing, if I'm pumping on this or doing any operation, it will know how far I have rotated as it's rotating around in doing this, and it will cut deeper based on where we are in the profile and where we are in the rotation of that.
Yeah, I think that's going to be a lot of interesting capability.
I hope so. All right, I don't have anything else, but I'm happy to answer any more questions that anyone has about anything, except for enzyme kinetics, because I'm teaching that over the next couple of weeks, and my least favorite topic to teach.
I have no questions about enzyme kinetics. You're off the hook.
I don't even know what it is and don't think I don't want to.
I have a quick question on the probes.
Yeah.
There's two types on that Amazon link from your site.
Yeah.
One says NC and one
NO.
says NO.
Yeah, it's either normally open or normally closed. You can use either one. By default, the settings that I have are for the normally open. The normally closed might be better. I think it costs a little bit more.
Actually, it's less.
Is it?
But there's
Okay.
a difference in the wires that it comes with, and
shouldn't be dramatically different, because
on one of them it looks like it's got the C connector, but on the other you can't see that. I'm not sure why.
There shouldn't be any difference. So the only difference you would have, and you can get either probe, you just have to, there's a parameter that you change that tells it whether or not, basically just says whether or not you put a pull-up resistor on, whether the board should put a pull-up resistor to have your signal be high or your signal be low to start. So
Is that a setting in the LatheEngraver software?
it's a setting for the board which you can access from the software. So if you go to, if I'm ever talking to you about settings for the board, you can go to LatheEngraver support here. And then when you scroll down, these are all of the values for that. And it's this value here. So the probe pin, in this case, it's inverted. If you got the other one, you would switch that value to 0, and it would work correctly. So that's the only setting that you would change to be able to.
So the NC is less. It's on sale, and it has the correct C connector. So I'll do that one.
Yeah.
And
what's the current price on it?
$62.40.
I was hoping for a Black Friday deal.
Yeah, the other one is $68 with no discount for the holiday.
Oops. Can you pop that in the chat?
I can.
Please. And then, Paul, you said the header for that is on Discord, you think?
I think it's somewhere there. I'll put it up, and I will put it into the building section, and I will also give it a whatchamacallit, a sticky or whatever it's called. So you'll be able to, it'll always be present, basically.
Perfect. Thank you again. And thanks,
welcome.
Scott, for the link.
Yeah, no worries.
So, Paul, maybe a future topic. I know you spent some time making adjustments in the settings to compensate for any play misalignment of the assembly. Maybe that's something you can cover in a future topic on how to compensate.
Yeah, so it will do it'll do backlash correction. Yeah, I can do that. So just the sort of the long and the short of it, you get a dial indicator, right? Like so, and it's really quite easy. There's not a lot of backlash. It's pretty small. The only time it's like about all the measurements I have is about like 0.02 millimeters of backlash. The only time that comes into play that I found is if you're doing when I've seen it is when you're doing a lasering job, and you're going to laser around a very large object, and you're doing a lot of filling because it's going like back and forth over and over and over again. And by the end of that job, you can see that it's off by a small amount. So yeah, I can do that as a future topic. That's a good idea. I'm still contemplating, I think I talked about this last time. So AAW will let you list your demos for like $25 in the email newsletter that goes out. And I'm thinking about when would be the most opportune time to do that, to give a general overview with the idea that it would be, most of you already have a LatheEngraver and have things set up. So it would be something where it would be to introduce the machine as a whole. And I think I would probably wait till maybe March to do that. But that would be another one that I'd like to do.
How many people can you handle on a Zoom meeting?
Well, right now, since I'm using my university account, I think I can use, I don't think I have a limit.
Yeah, you can do at least 100, probably, maybe way more.
I know a lot of them are set for 300, and one of my turners that I follow, he did a Zoom event where he had over 300 people sign up, and he was worried.
Oh,
But
wow.
but he fell into looked at statistics and just fell to what those would show him. Says usually half the people that sign up don't
Yeah.
attend, so it worked out for him in that case. But he was worried.
I seriously doubt that I would get even close to that many, but it would be nice to have introduce it to other people as
Well, he
well.
did the same thing. He put it on the AAW website, got him to put it on there, and it went up tenfold from what he expected it to
Oh,
be.
wow. Okay.
So it could happen.
All right.
I have another purchase question.
Sure.
So looking at the router made for the Shepeco, I'm not sure how to say that. I guess it's for CNC machines. They have a kit of cutters that you can get. Can we use all the different shapes? I'm not really sure which ones are appropriate.
So probably, yeah. I mean, if they fit in the router, you can use them. For me personally, I think I'm really only using 3 different router bit sizes right now. This is pretty much all I've used, which is the 3/32, the 1/8 inch, and the 1/4 inch.
Just using what, flat cutter or ball cutters?
I'm the common both of them. So in those sizes, that's what I've used. Occasionally, if I'm doing like very fine detail, I'll use the 16th inch cutter, or even using a V bit, like I don't know if we can see this in the camera at all.
Yeah, they have 90 and 60-degree V bits or V
Yeah,
cutters.
so the 60-degree V bits would be could be useful for things if you're trying to engrave. This is a 60-degree V bit. Actually, that's a chamfering bit, but I just use it as a V bit.
So the ones that they have in that kit are very large. So they look more like standard router bits that might not be appropriate.
Right. So my go-to source is Online Carbide. They have all of those sizes that I'm using, and others, and they seem to be they're in line with the stuff that you can get from China. They're $4 or $5 for a bit, and I just buy 4 or 5 of them at a time. The only other thing that I've been using, and this was in the last meeting video, is for doing threads, because I'm doing almost entirely doing square threads now, is using the 16th inch. It's a 1 inch by 16 inch slot cutter. And I like that for doing threads as opposed to using a thread, very expensive thread cutters that will do 60-degree threads. For wood, it just seems to make a lot more sense to me to do those Acme threads or Acme style threads.
That I put a link here for the cutter page, but it looks like most of those aren't really needed, and they're a lot more money here, I would say.
Yeah, I would.
Some of these V cutters are $70 for 2 of them, and they're
I would go to Online Carbide and just start with start with some 1/8 inch and some 1/4 inch, and some of those. The 3/32, if you're gonna, because all of the template files I think are either 3/32, or there might be one or two that are 16th inch cutters. So that's 2.38 millimeters or 1.59 millimeters.
And the ER11 setup has the 1/4 inch and 1/8 inch collets.
Yep.
And do you have to buy the other collets for 16th and 3/32?
No, because those have 1/8 inch shafts. So you'll be
Oh,
using 1/8 inch shaft for pretty much everything.
Fine.
Except the 1/4 inch. You'll be using 1/4 inch shaft for that.
Very good. Thank you.
The other thing which I will make available, which I haven't yet, is my little pen. So the pencil thing is better for when you're on wood, but this pen it's a 1/4 inch. It's just a ballpoint pen. There's a certain style ballpoint pen you have to use, but I just cut it off and I put those springs in the bottom of this, so that it's basically just a spring-loaded pen. That I do that for the paper chucking on the ornamental stuff. And so I'll make that STL file available for 3D printing.
Oh, you mentioned you have an auto switch for your router. Are you using an M code to turn on some remote switch?
No, actually, so I'm doing some things that are like not entirely standard. So the neat thing about Octoprint, and one of the reasons why I use Octoprint for this, is that all of the different plugins that you can have. So I'm actually using MQTT. So I have an MQTT host in my house. So when it actually it'll send events to all of this. So like the topics that it'll do all active event messages. So all the printing events. So when I click start a print, that goes to the MQTT server. The MQTT server then sends to, I have these Wi-Fi connected. Let me go to this view here.
You're using like Shelly? Oh,
They're not
Tasmodo.
Shelly's. They're
Sonoff.
yeah. So these are just Wi-Fi connected switches that will then automatically turn on, and it'll do other things like, it goes through Home Assistant, which is the home automation that I use. And I can set it up to basically do anything. I can turn on my vacuum collection. I can turn off, I have it set up so it'll turn off my vacuum collection when the job ends. So, it's just like a bunch of automation things.
So are those Sonoff that you've reflashed with Tasmodo or something like that?
No, they are all the Tuya versions, but I have it all run on Tuya local so that it doesn't go back to China. So
Okay. Yeah.
I didn't have to reflash them in order to be able to do that.
Yep.
I would
No,
switch everything now. So if I had it, I can't remember what the name of the devices are that I like now. Just as far as ease of setup, let me see.
I'm using a bunch of Shelly because you don't have to deal with the flashing and they just work.
Yeah.
And they actually have UL certified switchable outlets now.
The Shelly things that I have some of the power consumption devices to be able to monitor. I'm trying to remember what
You haven't had any issues with latency of turning things on and off?
No, I have had a couple of cases where Wi-Fi has been disconnected and I didn't know it. And so I'm always like kind of ready as soon as I start a job. If the router doesn't spin up in a couple of seconds, I can just go over and I can click the button and that'll get it going. So I do have, in most things, I have like a 2-second pause before it'll actually move and do things, so that I can have that 2 seconds to flip on the router if needed.
I wonder if no, off topic. I was going to say, I wonder if it makes sense to have another instance of Home Assistant that is just for shop related stuff. So you don't have any issues like that or any overlap or errant behavior.
Yeah, I think I found that I've done enough things that are that are tied together that I actually probably wouldn't do that. Like I had some cases when I was still out in the shed, I would have like a little space heater running, and I could set a timer that would make sure that it turned. I mean, that would, I guess, would still be shop related, but it would turn the timer off, or anytime like I would turn the light off, it would make sure that it would turn off. Or in cases where it was too hot, it was very hot, I would have, when it got above like 80 degrees, I would have the fan switch automatically turn on to start cooling the shed off before I got in there. Little things like that, which I guess that's all still shop related, but
For the control board, is there any inputs for things that you can validate that they're running?
um,
Like maybe a
yes, there.
current flow for like the router. Yeah, it's on. I can proceed.
Yeah, there are actually. There's actually quite in that firmware that I'm running on that board has a lot of that stuff. Most of it I have not set up because it's not really necessary. I mean, there is, I should say that there is a spindle on, so it does turn a signal on. It goes to from a low to a high. When you turn on when it starts a job, when it gives it the M3, which is the start for the router and the G code, that can be linked to a relay, which would then directly turn on the router. And when it sends M5, which stops it, it would turn it off. So there's other hardware you can use. I've just used the remote switches because that's what I had around.
And if
And
you
in fact,
did use the
my little
M3 and
milk
M5,
crates. What's that?
if you did use the M3 and M5, you could potentially use, like feeding a relay, you could then use the contacts on the relay to not only turn the router on and off, you could also use it as an input signal back to the control board saying, hey, yeah, I've confirmed I gave it the signal.
Yeah. So yes, if you set up the input, so there's actually more outputs. Outputs are easier to configure than inputs in that sense because I don't know exactly what the one is for that control board that says there's like a spindle up to speed. Like I know that's one of them, so that it won't actually start cutting until the spindle reaches full speed, and so that would be an input that you could put in.
Yeah, I think for the cases that we're doing here, it's pretty much instantaneous. I can see that being for a large industrial piece of equipment, but I don't think that would be necessary for us.
Right, but you could. I'm saying you could kind of use that.
Yeah, you could, I see what you're saying. Use that for I'm actually operating.
Right.
And there are, not to go down the home automation route, but there's some Shelly devices that have low voltage side switching so that just a contact is made, it'll switch on the line voltage side. So it's kind of an all-in-one thing you can use to do that without any other logic. And so the M code could still turn it on.
Yeah. Sure. Yeah, there are quite a few things out there, and I was saying that my little 3-axis CNC that I cut things out on, it has one of those basically. So I don't ever worry about that, and I still use Octoprint with that, but I use that to turn on chip collection and dust collection. So that's what I use the automation for there. The router comes on automatically from the board.
Hey, if any of you guys need the router or want to get an extra one, they're also on special today. They have that.
Even more special.
Yeah, $51. So yeah.
Wow.
Can you
Can't
add
beat
that
that.
link? I haven't done that yet.
Yeah, I have to go back. Hold on.
All right, starting to get more expensive.
Well, these, for some reason, people didn't want these ER11s. They've sort of standardized on the one with the 1/8 and 1/4 inch.
It's crazy because when Open Builds was selling the Router 11, which is the other just one of the other knockoffs of the 65 millimeter Makita router, it was impossible to get them. They would sell out right away when the 115 volt versions would come in. You could still buy the 220 volt versions, but now, like, I guess nobody wants them.
Yeah, they're standardizing on the others, so they only have whatever they have left. But it comes with a 1/4 and an 1/8 collet, so it works fine.
think
They
they've been
were
on special now
60.
for about 5 months.
Oh, but they were $60 on special, and when I put it in, it took money off, so it's less than 60 now. So
Nice.
good timing.
That's the one on Carbide 3D, right?
Yeah, it's the Carbide ER11, $60. Their standard one is 80 plus. 80 was on sale, I think.
Yeah, that's the one I got after I
Yeah.
got my unit, and they had it. It's been on sale for a while because nobody seems to want these anymore, like Paul was saying, which surprises me.
Oh,
Yeah, there's
well,
because there's
what's the
no
one
difference.
that's slower? Paul, is that a different?
The router that runs slower, the one that I know of, is Margaret still here? Margaret's not here anymore.
Yeah, she's here.
Yeah,
I
I'm
don't.
here.
Oh, okay, you're here. Good. I'm trying to find mine. I don't remember what the name of it was. Oh, here it is.
Oh, and I don't either. It's right here.
It is a Jinmitsu,
Yeah, Genmitsu.
and it's the GM 77100E. And
Say
that
that again, and how do you spell it?
it's it's GENMITSU, and the
Put it
model
in the
number
chat.
is GM dash 7100E, and it'll go down. It says 7,000 RPM is the low, but I've measured it with a laser tack, which I think is pretty accurate, and it was more like around 6,200 at the lowest setting, which seems to work pretty well for when I attach the cutting frame to it.
You say that it's Genmitsu GM-7100E.
Yeah.
GEN.
GEN Genmitsu. And
Genmitsu.
where'd you buy it from?
Online.
I'm fairly sure it was Amazon where I got mine.
Yeah, it
Is
was
it
Amazon.
Would it be a 710W compact router?
Hang on, I'll fetch the box.
Oh, speed range of 6,500 to 30,000.
Yeah, that's it.
$103.
Yeah, that sounds about right.
I see it.
Yeah, Genmitsu 710W.
And that's what you're using for the cutting frame.
That is what I'm using for the cutting frame.
Okay. Thank you.
Now, I should say I haven't looked because I had bought that one a long time ago, and I just started looking for one that could go at a lower speed, and I happen to have that one. So there might be other cheaper ones out there that are 65 millimeter that'll go at lower speed. So I've done no experimentation yet.
This
I
one
was
goes
looking
in.
at some. Sorry.
Go ahead.
I was looking at some when you mentioned somebody had gotten one of the square bodied, and I was looking at trying to get like up to an ER16 or something. And there are a lot of brushless ones out there, but I wasn't sure. That's when I was asking you an email about center height and what you have to do for the tool platform, because it seems like the square bodied ones are all, radically different dimensions.
Yeah, so that is that's like the real unknown with this, is that there's the minimum height basically that you have from the components, and then you have to be able to fit whatever that router is on center. I think some of the square ones will work. I mean, if you're doing mostly ornamental stuff, a router, because a lot of those brushless ones, they'll say that they go to 13,000 or something. That's almost on too slow a side for some of the deeper cuts with like a 1/4 inch end mill that you try and do. So the router has a lot more power or the speed is necessary when you're doing like some of those fluting cuts. If you're only going to do ornamental stuff, you could definitely use one of those brushless DC motors to drive a cutting frame.
Yeah. Well, and I'm kind of going back and forth between driving a cutting frame and driving an actual axial tool, like, some of the V bits. They make 120, 130-degree V bits too. And so
Right.
we've been playing with a lot of those. And if one's acceptable and the router has the power to spin it, that might play.
Right.
Do you have a link to the cutting frame anywhere?
I don't. The cutting frame is, let me just say, the cutting frame is still under development. The things that and there's not that much to it. Like there's not that much more to develop on it. Let me take off this pen and I'll throw it on there so you can actually see what it looks like. Ow. So I think CW, I think you saw this on the you were there for the OTI.
Fundamentally, yeah. Great demo, by the way.
Oh, thanks.
Yeah, definitely a lot of interest from those guys.
Second and third that it was a great demo, and it was a very big eye opener for a lot of people, I think.
So there's the cutting frame on the router. So the things that are, so let me say that the mounts and the actual, the cutting frame portion itself, I can make that available to anybody who wants it. If you want to have these things cut out of, so I've cut them out of 1/2-inch aluminum on my CNC. You could send that to Send Cut Send. They'll cut it for you. I don't know how much it would cost, but basically it'd be 3 pieces. This one main piece, and then the 2 pieces for the frame here, the smaller piece and then the larger piece. The main things that I'm still sort of, and there's the 3D printed drive gear, I guess. So that is, I print that out of flexible filament, so that you can kind of adjust to get things on center, and you don't have to worry about it being rigid at the center. The wheels are kind of the things that I don't know if I like them yet.
Polycarbonate?
What's that?
Are they polycarbonate?
Yes, they are. And these are just the wheels that I had for a lot of my open build stuff. But what I've done is I actually put them on the lathe and I cut a groove down the center of them. Because what I tried to do is I tried to use the stainless steel versions of these that had an actual V in the center. And I thought, that'll be fine. You'll get enough friction from the belt that'll work. Complete failure. I had to actually use the larger diameter of the wheel rather than having the V. And I just cut little, you can maybe see, I just cut little grooves in there on the lathe.
What's the material that is the green material?
That's the standard, it's a urethane belt, right, John?
Yeah, it's typically urethane round belting. You can find it. McMaster-Carr sells both the orange and the green. The green has more tooth to it and it stretches less. And there's also a clear belt. The green typically is in metric, so it's 3 millimeter. And the orange is usually in imperial, so it's 1/8 inch and other sizes, but the size that we use for the cutting frames typically.
Yeah. The green, there's no way you'll see it here, but the green is textured. And that was the recommendation that I saw in all the OTI stuff, or the book of knowledge, was to use the textured stuff. And I bought some in I think it's 2 millimeter and 4 millimeter, or 2 millimeter and 6 millimeter. I'm not sure.
It looked like what you had is the 3 millimeter, but I'm not sure.
Maybe, yeah.
You fuse it with
heat? You actually heat it and melt it together, correct?
Yep.
Yeah.
So the easy technique is clamp a utility blade in a vise, heat it with a propane torch, and then put the 2 pieces on each side and sort of drag it towards you off of the blade to make the joint.
Yeah, we had professional kits for that, for making belts back when I was in maintenance, and it was a little bit of a technique to it. Like you said, you don't want to just pull it off the heated blade, because a lot of times you'll leave melted material behind. And and the belt will break pretty quick.
There's an art to it, and it's a skill that you learn, but and it has to repolymerize too. So it's like, don't try to make the joint and use it immediately.
I made that mistake.
I was going to say, don't ask me how I know that.
What time frame do you think your cutting frame will go from almost ready for prime time to prime time?
Well, I mean, if you're willing to, it's basically there in the sense that it works. I know that it works. What I don't know is if it works as in the best configuration that it can. So I haven't made any other versions yet. The one thing that I like about it is that all of the bearings are the same size. So you only use one size bearing for both the wheels and for the flying saucer. So I modified Ed French's flying saucer piece here. So this is 3D printed as well to use the same bearings that the wheels use. And then it's just a shoulder bolt here. I don't even think you need a shoulder bolt actually. There's enough play on the shoulder bolt on those bearings that I think even just a 5mm bolt going through this is enough. If you want to make one, I can give you all of the diagrams and even the the 3-dimensional files if you want to look at it.
I mean, if you would, because I belong to a makerspace that has a Tormach CNC,
Wow.
and so I need a project to take a class in it anyway, so I might as well do this.
Sure. There are a couple of holes you have to drill too and tap things, but that's easy to do.
Yeah. And while I'm here, hi Pat.
Hey there. I just ordered from that the Genmitsu link that I put up, and the shipping is free right now.
Is that the one, the woodstarters.com one?
Yeah.
Okay.
And I did see some cheaper
$79.99.
sites, but they look questionable.
$79.99. It's 103 on Amazon.
Yeah.
Yeah.
We'll see.
Wattage.
I had a question. That green belting, doesn't that have a filament through it so you get less stretch?
I don't think the green one does.
No, I think it's just some sort of they may have some other material in it to help it be less stretchy, but it doesn't have like a core.
Yeah, nothing that's I can visibly see on the end. But it's not real stretchy. All right. Well, I mean, keep going. If you got more questions, I'm just about out of water, but not quite.
This has been really great, Paul. Thank you very much.
You're welcome. And thanks for the ideas. I mean, I don't know what we'll do next time around. Maybe, I don't know, maybe I'll do more of the ornamental stuff because that's been a lot of fun recently. So, though, I don't know, I could even go back to doing some of I think that to make it, the customizability of making your own inserts, your own things would be nice. And we've talked about that a little bit, but maybe even just going through all the actual steps in one of these would be a good one to do. So starting with, maybe making a circle and then cutting the pocket in a bowl and then cutting out the circle on a piece of flat stock on the LatheEngraver and then popping it in might be something else to try out. All right. Well, thanks again, everyone. And at some point, we'll have a video of this. I may edit it a little bit. I'll put it up on YouTube to watch, and we can re-reference things. Have a great rest of your weekend.
Paul, thank you so much. Appreciate it.
Yep.
Yeah.
Thank you.
Good to see everyone.
Thanks, Paul. It's been great.
Yeah.
And
Thank you.
and I'll send you info about next month via email initially, and also on the Discord. So it won't be a full month away. I can promise you that. It'll be like 2 to 3 weeks. So it'll happen sooner.
Are you saying 1225 is off the table?
Yeah, I think probably.
And thank you,